how to calculate the percentage intensity of isotopic peak with respect to a specific element in molecule. See, what we'll see in this, if you see the slide, this one, you will find that there are certain important elements which present in organic compounds. They have their natural abundance as shown here. For example, carbon, just there are two isomers of isotope of carbon, carbon 12 and carbon 13, and carbon 12 is 100%, while carbon 13 is 1.11%. Actually, it is sum of carbon 12, carbon 13 should be 100, so it should be 98.9 like that percent. Similarly, this hydrogen is also almost 100%. However, its isotope H2 deuterium is 0.016%. Other elements are nitrogen, oxygen. You can see sulfur here also. Sulfur is about two isomers of sulfur, 32 and 33. So it is higher or heavier isotope, we can say. This higher atomic mass is called as a heavier isotope, which is 4.4%, and lighter isotope is about 95.6 there. Here. Chlorine, if you go for chlorine, you will find that it is lighter isotope Cl35 is 75%, and Cl37 is 25%, and bromine is almost 1:1. Bromine heavier isotope, there is a this one 81, and lighter isotope 79. They are 1:1 or 100% or 98% is almost same. So when these elements are present, so what is their percentage intensity? So by using the binomial equation, we can easily calculate the percentage intensity of these elements. For example, this is the A plus B bracket to the power n. If you go for the calculation, so first we should know what is n. N is the number of selected atoms. So n is the number of selected atoms in the molecule we are discussing on the mass mass spectrometry. This A is very important. A is the percentage of lighter or the common isotope of element. See, this is very important. This A is the percentage of lighter or common isotope of element. For example, if we are taking carbon 12 and carbon 13, so A is the carbon 12 percentage, and B is the percentage of heavier isotope of element. Right? So like this, we have this formula binomial equation. By using this, we can find out the percentage intensity of isotopic peak. See, suppose the most important part is what the chlorine and bromine. Remaining elements do not interfere or they are easy, but chlorine and bromine they give a very prominent isotopic peaks. So what if we have one chlorine atom? Let us take example CH3Cl, and we know chlorine has two isotopes Cl35 and Cl37. So this molecule have only one chlorine atom, you can see. When we do the electron ionization of these methyl chloride sample, this chloride sample, methyl chloride, and we should know what is the ratio. This ratio is this chlorine is this present is 375%, right? And this 75%, and this present 25%. We know this, right? We can say 3 is to 1. What is 3? It is a percentage of A and this percentage of B. Yes. Remember this point. Now, so they form like this ion, molecular ion, 35 and 77. When you go for the mass spectrum, they give molecular ion peak like M plus and M plus 2. We can see here. But question is, what is the intensity ratio of these two peaks? That is a very important question. What is the intensity ratio of these two peaks? So to find out the intensity ratio, we have this equation that is A plus B to the power. Now put the values for this CH3Cl. For this CH3Cl, we have two chlorine isotopes, 35 and 37. So A is equal to 35% is a percentage of lighter isotope. B is the percentage of heavier isotopes. So 3 is to 1%. N is the number of that elements that we are discussing chlorine. Okay, so now then simplest ratio from A and B ratio would be 3 is to 1. And if you put the value, you will get like this peak ratio. Peak ratio means that M plus peak or molecular ion peak would be 3 times more intense compared to the peak which is coming from, yes, M plus 2, right? Ion peak. So this is the way by which we can find out the number of isotopic peaks as well as their percentage intensity by using such method. If you go for if you go for the another example in which molecule having the two chlorine atoms, say this is the possibility. Here we have shown directly their molecular ion CH2 Cl2 you have taken. So what are the chances of two chlorine? So these two chlorine could be could be 35, 35, or they can be one of two is 35, another will be 37, and both chlorine possible. So the three possibilities are there, not more than three possibilities, right? Yes. So the isotopes which are present, there are Cl35 and Cl37. So in this molecule, we have taken both the Cl35 here and 135 and 137, and another, then we have taken another example 37 and 37. If you consider this as a M plus, so what do you say for this? M plus 2, right or wrong? Yes. And what do you say for this? How many this increases mass by 4, so we can say M plus 4. So there are three peaks, expected peaks. If there are two chlorine, the number of peaks are 3 in the mass spectrum, total isotopic peaks. And if you say if there are 3 chlorine atoms, the peaks would be 4. And like that we can find out. So calculate, let us go for this calculation. So suppose this is M plus 2 and M plus 4. Okay. How this is formed? M plus means 35 means lighter isotopes of chlorine we have taken. Here 35 37 means one is lighter, another is a heavier isotope, so M plus 2. And in this case, Cl 37 means M plus 4. Okay. So like this, okay, fine. When you go for the mass spectrum, so three peaks are expected like this. Okay, three peaks are expected, isotopic peaks. Question is, what is their percentage intensity? Question is, what is their percentage intensity? Okay, so see, so formula is same. A plus B to the power n. So what is here? N is equal to 2 number of atoms. N is equal to number of atoms 2. And same, we are taken chlorine. So percentage of chlorine, there's a lighter isotope 75 and B is 25. Okay, now we put the values. So now you expand this binomial equation and you will get this expanded form. So now this is what the further calculation, and you will get this one. So this is what, see, 9 is to 6 is to 1, and therefore if we are making this or multiplying this by 11 to make this 100%, so this is the expected intensity ratio of the peaks. Okay, so that's M plus 4 peak would be 11%, and this M plus 2 peak would be 66%, and this m plus p could be the 100%. Fine. So if you draw the peaks, so this is suppose 100%. So m plus 2 will be compared to that is 66, and this would be around 11%. So like this percentage can be observed in the true mass spectrum. These theoretical values which we have found just now we have calculated by using the binomial equation. We can also observe this in the true spectrum. Okay. Yes. Fine. So these three peaks are corresponds to the first left side is for m plus, is m plus, this peak is for m plus 2, and this peak which is very less in percentage abundance, that is because of m plus 4. Okay. Yes. So like this we can go for further. Okay. See if molecule is having three chlorine atom. This is again another example. Molecule is suppose having three chlorine atom. Okay. So these are the possibilities. What are the possibilities we know? Chlorine 35 suppose or three chlorine. It's a chloroform, example of chloroform. And another example, what another possibilities means out of these three lighter isotope, say one of them is 37 and two are lighter, one is heavier. Similarly, in the third possibilities out of three chlorine, say two are heavier and one is lighter. Okay. And in the one more of possibility is in the last option, see all the chlorine atoms are heavy isotope or heavier isotopes means so that is what it is. So if you see the lighter isotope, or we call this as a common isotope, which is a 75% out of 100. See here, 35, that is labeled as M plus. When out of these three chlorine, one is replaced by heavier isotope of chlorine, that is 37. So say it is a M plus 2 because increment by 2 in the total mass. There is an increment by 2. Okay, right. In the next, say there are three chlorine atoms. So out of three, two are heavy isotope, one is a common or a lighter isotope. And in the last one, all the chlorine are of heavy isotopes. Therefore, M plus 6 speaks. So when such a molecule is there in which, and it is not mandatory that three chlorine should be on same carbon. See, it is many. See, we have taken for our understanding. You can take trichlorobenzene, okay, like that. Or many examples are there. 1, 2, 1, 2, 3 trichlorocyclohexane, 1, 2, 3 trichlorocyclopentane. Many possibilities are there. Means we are talking about total number of atoms, selected elements. So in this molecule, we have selected only chlorine atom. So remember the point. Irrespective of the size of the molecule and number of elements and atoms, there is no effect and position of element also. You can take any compound. If that compound contains three chlorine atoms, so these four possibilities are there. Okay, hope you understand this. Any molecule, any molecule if which contain three chlorine atom, so this is the possibility. Any molecule which contain three chlorine atom. Okay, so these are the possibilities. There are four possibilities: m plus, m plus 2, m plus 4, and m plus 6. These are the three possibilities. Okay. See, now what is the percentage ratio? That is the important point. What is about their percentage intensity? Okay. So if we are taking three chlorine atoms, okay, so how to calculate these? How to calculate these? So see, this is the formula we can use here: a plus b to the power n, where n is equal to 3 now. This n is the 3, and a and b will be remain same for chlorine, and a and b simple ratio is 3 to 1. Okay, now you go for the expansion of this binomial equation that gives a cube plus 3a square b plus 3ab square plus b cube. And by putting the values, you will get this ratio, which can be written less like this. Okay, so understand this idea. So you can see from this that m plus and m plus 2, this is the ratio of m plus peak, this is the ratio of m plus 2 peak, and this is the ratio of m plus 4, and this is the ratio of m plus 6. So these two are same. So while writing this, we can show like this: these two peaks out of 4, they are of same intensity, which are in right left hand side, and these two peaks are in the ratio according to calculated by a plus b binomial equation. Fine. So these are the simple ratio, or by which we can find out the intensity of peaks related to how many elements are present in the given sample. Okay. So these are the labeled peak like this. So don't get confused here. M plus and M plus 2 peaks, they are equal. So you may also get confused. There are chances of confusion when you go for bromine. If one bromine is there, so such peak also arise for M plus and M plus 2. But if you see, look at this another peak which is a red difference of M plus, again plus 2 difference. So M plus 2, M plus 2, and from M plus 2 to M plus 4. So this by a difference of 2. So we can easily judge. Okay, fine. So now, what do you think? If bromine is having, if the atom is having one bromine, a compound is having one bromine, see here. So we know the percentage abundance of bromine is, yes, that is of lighter isotope is 79, which is 100%, and of that bromine 81 is again 19, means again 1 is to 1, means both the elements, bromine 79 is a lighter isotope and bromine 81, that is a heavier isotope, they are in equal amount. So see example of CH3Br. So two possibilities are there. Okay, so two possibilities are there, m plus and m plus 2. But how to calculate by using this equation? So very simple again. So very simple. How we can find out? See, you put the values. We have the formula, that is a plus b to the power n. Yes, right? Yes, to the power n. Now put the values so we can write. See, what is the value of a? For bromine, A is equal to 1. What is the value of A for bromine? Yes, just now you see here. A, see, A is equal to 1. B is equal to also 1. Right? B is equal to also 1. What is the value of N? N is equal to also 1. So what is the ultimate ratio? Yes, how we can write? If you write in the bracket 1 plus 1 to the power 1, binomial expansion, okay? So that will give you 1 is to 1. The ratio is what? 1 is to 1. The ratio is 1 is to 1. Means both the peaks are will be of equal ratio or with equal intensity. So how we can draw the that if we want to draw the mass spectrum, you just write like this, and you can show the intensity peak ratio of this of equal intensity. Okay, yes. So straight line should be there. So 1 is to 1. Okay, this is M molecular ion, and this is what? M plus 2p. M plus 2p. It is for bromine. It is for bromine. If bromine have, if the compound have only one bromine atom, so two possible peaks are there: M plus peak and M plus 2 peaks. Okay, all right. So all of you understand this. But my question is, if compound is having molecule having two bromine atom, if molecule is having two bromine atom, so what are the possibility? Okay, if molecule have two bromine atoms, so what do you say? If molecule have or compound have two bromine atoms, so what are the possibility? What are the possibility? We will take example. Same CH2 Br2. If you think about this, we can have the example CH2 Br2. See here like this. This is Br and one more Br. Okay. So see, suppose these two Br of lighter isotope 79. This is also 79. Okay. So what is another possibility? That can be of CH2. This would be 79, and consider this Br of 81. This is one possibility. What is another possibility? Yes. Another possibility is both the Br would be of higher, heavier isotope. Let us take CH2, one Br and another Br. See, suppose 81. This is also 81, suppose. This is also 81. So This is m plus, means lighter peak m plus. This is m plus 2 and m plus 4. But what is the question? What is the intensity? What is the intensity? So now calculate by using the formula. You find out. How will we find this? Yes, anyone? You just write a plus b to the power n, binomial equation. So what is the value of a? What is the value of a?
One.
A is 1 and plus again 1. B is 1 to the power. Yeah, what is n? N is the 2. So but before that we have to expand this equation, right? Yes, expansion. What is that? A square plus 2ab plus b square. Then yes, now you do this. So a square means 1 square means 1. 1 square. 1 square means 1 is 2. 2ab means yes. 2ab means 2 because a and b are equal to 1 and b equal to means 1. So 1 is 2, 1 is to 1 ratio. That is our answer. Means when you draw the peak, if you draw the peak, you will get like this. See, if you draw the peaks, so 3 peaks are there. So m plus peak, okay, m plus peak.